KDE present.
Indonesia faces increasingly complex challenges in managing an effective and efficient transportation sector. Urbanization, with the rapid population growth and increasing urbanization, the need for intelligent and integrated transportation systems becomes ever more urgent. The vast amount of data and information from various operational activities within the Ministry of Transportation is not well managed, making knowledge and experience difficult to access or utilize. Standardization, knowledge in transportation policy context dispersed across different units needs to be standardized, complicating the ability to make quick and consistent decisions. Silo. In many cases, knowledge tends to be individual and stored in silos, making it difficult to preserve or transfer to new employees. Data and information limitations. The lack of real-time and accurate data predictions on vehicle and passenger movements complicates planning and effective decision-making in transportation policy. Suboptimal infrastructure management. The absence of data-based recommendations on the location and timing of service improvements results in misaligned resource allocation. Responsive policy needs. Transportation policies must be supported by predictive analytics that can adapt to the dynamics of passenger and vehicle movements in real time. Inefficiencies in transportation services. Difficulty in predicting transportation demand leads to uneven and suboptimal services, resulting in user dissatisfaction. Regulatory complexity. Transportation regulation documents are often complex and technical, making them difficult for decision-makers to understand and apply. Varied quality of transportation services. Transportation services in Indonesia vary in quality across regions and service providers. The public shares experiences and complaints about these services online, but this data has yet to be fully utilized by policymakers. Lack of real-time public opinion monitoring. Monitoring public opinion remains ineffective, particularly in understanding how opinions evolve over time. Manual analysis requires significant time and resources, making real-time insights difficult. Need for knowledge-based mapping of transportation infrastructure distribution. A need exists to map the distribution of transportation infrastructure based on public knowledge and assessment. Smart transportation policy needs. A system is needed to support the implementation of knowledge-based transportation policies, powered by deep data analysis. To address these challenges, innovation and collaboration between various stakeholders, including research institutions and government agencies, are essential. This collaboration was realized through the signing of a partnership document on October 8, 2024, between the Research Center for Data Science and Information BRIN and the Transportation Policy Agency of the Ministry of Transportation. We are committed to collaborating in research to develop a knowledge-based system to support smart transportation policy. This collaboration has produced a prototype knowledge-based system named the Transportation Knowledge Hub System, TRAK Hubs. TRAK Hubs has 4 main features. The homepage displays the main features of the knowledge base. This homepage consists of several sections, namely, Features section, knowledge content categories, knowledge statistics, multimedia, testimonials, content search, and FAQ. The first is the Knowledge Base System (KBS) and Best Practices Database. This feature serves as a repository of knowledge and best practices managed by the Ministry of Transportation. This feature is gamification-based to support participative knowledge management practices. The KBS includes a performance monitoring dashboard for leadership. KBS also includes statistics on knowledge content utilization. The second feature is traffic prediction for passengers, vehicles, and transportation facilities. This feature can predict the number of passengers and vehicles at transportation facilities to support responsive policy. It provides recommendations for locations and times to improve transportation services. This feature also displays a facility gap index. The third feature is a knowledge-based chat system based on large language modeling and retrieval augmented generation. This feature addresses the challenges of large information volumes and the complexity of Ministry of Transportation documents by enabling information and knowledge searches based on conversational chat, such as legal documents with specific contexts. Additionally, users can perform text generation in the context of data and knowledge about transportation policy. This feature facilitates understanding of documents and explicit knowledge, such as ministry regulations and transportation documents. The fourth feature is transportation facility sentiment analysis. With real-time sentiment analysis based on public assessments, these dynamics can be understood swiftly, allowing policy responses to be more responsive and relevant. This feature addresses the challenge of monitoring public assessments as policy recommendation support by providing information on sentiment percentages from each location point of transportation infrastructure, helping policymakers understand public opinion dynamics in real time. Monitoring public assessments based on sentiment in a single dashboard related to transportation facilities. The Infrastructure Map dashboard with sentiment values and detailed information offers a visualization that eases location-based decision-making. This prototype and collaboration are expected to be a strategic step in addressing future transportation challenges. This system will continue to be developed to support smart transportation policies and is anticipated to make a significant contribution to creating a more efficient, safe, and sustainable transportation system in Indonesia.